exponential properties, second assessment. This first part's very easy. -4, you just have -4 as a factor 3 separate times. That's going to be -64 as a product. -2 to the 4th means I list out -2 as a factor 4 times, and that gives me +16 as a product. That one's a negative product because my base was negative, and when the exponent, the power's odd, you'll still have a negative product, but if the power's even, you won't. You'll have a positive product. 3/4 times 3/4. 3 times 3, 9. 4 times 4, 16. 6 to the 3rd means 6 times 6 times 6, and that's 216. Now, many of you did not do very well on this standard because of the next part I'm about to go over. And again, I'll take some of the blame. It's probably a little bit of my fault, and it's probably a little bit of your fault, so I'm willing to share blame. But that bottom line is it's stupid to blame. We have to do some different things here. Okay, now before I draw out the little boxes for this, and the reason I'm using boxes is simply because I don't have any addition or subtraction. It's all multiplication or division or whatever. So first thing you do is underline that and make your 3 boxes. Now, the first thing I do is make sure that every base has a direct exponent. So you see that big 7? There's no direct exponent here. Put a 1. C has a direct exponent of 7. D has a direct exponent of 2. Okay, so all the big stuff has direct exponents now. Bases are 7 times C times D. There's only one 7. I take the 1 times -2. That's -2. The C, I take the 7 times -2, and that's -14. The D, I take the 2 times -2, and that's -4. Now, you see a negative there? You do. It goes to the bottom so that the power becomes positive. Do you see a negative there? You do. It goes to the bottom. The power changes to positive. Do you see the negative exponent there? You do. It goes to the bottom. Power's positive. You need to cover your top with a 1. 1. 7 to the 2nd power is 49. C to the 14th, you can't figure that out. And D to the 4th, you obviously can't figure that out either. Okay, next problem. Go look at all your big stuff. Make sure there's a direct exponent. 4, y to the 2nd, x to the -3rd, y to the -5th. So we're good. The only bases you have are x and y. If you repeated that, you don't repeat letters. Okay, I've said that in class 35 times. You don't write the same letter down twice. X's, there's 2 of them. You have a 4, comma, -3. Now, a lot of people got that and just multiplied them. You don't. This is adding or subtracting. So I go 4, -3. Now I gotta pay attention to where they're at. They're both on top. If they're both on top, we plus them, and that gives me 1. So x to the 1. Now y, we have 2 of those as well. We have a 2 and a -5. Now don't times those. You have to either add them or subtract them. That's on top, and that's on top. So again, we will be adding those. That's -3. Okay, x to the 1st, that's positive. It stays on top. That's negative. It goes to the bottom where it becomes positive. Now the problem's pretty much done because you can't figure out when the base is unknown as a variable, you can't figure it out. That's just going to be our answer. Okay, this problem here is kind of a cheap shot. Okay. 2 direct exponent would be 1. X is direct exponent 1. 5 direct exponent 1. X has a 3. Y direct exponent 1. Z direct exponent 1. 2 would need a 1. X already has a 4 as its direct. Y with a 1 as its direct. And Z has a 7. So they all have direct exponents now. And now you're going to want to make kind of a wide box for the first part on this one. Boom, boom, boom. Okay, number bases, I have a 2. And I'm not going to repeat 2. I'm just going to go to 5. It's all on top. And then we have X. We have Y, we have Z. Now look at our 2's. I've got a 1, but then there's another big 2 here, and I take 1 times 2 is 2. You're going to plus those because they're on top, both of them. That's 3, 2 to the third. 5 has a 1. 1 times 3 is 3. I have 3 x's. The first x has a 1. 3 times 3 is 9. And 4 times 2 is 8. They're all on top, so just add them. 1 plus 9 plus 8. Last time I checked, that's going to be 18. Okay, now let's look at the y. Here's a y. 1 times 3, 3. Here's a y, 1 times 2, 2. That gives me 5. Okay, z. Here's a z, direct exponent 1 in parentheses, 1 times 3 is 3. Here's another z, 7 times 2 is 14. You can just add them because it's all on top, so that's 17. Okay, now 2 to the third. There's no negative, keep it on top. 5 to the third, no negative, keep it where it's at. X to the 18th, no negative, keep it where it's at. Y to the 5th, no negative, keep it where it's at. And Z to the 17th, no negative, keep it where it's at. Okay, now 2 to the third, 2 times 2 times 2 is 8. 5 to the third, 5 times 5 times 5 is 125. Times x to the 18th times y to the power of 5 times z to the 17th. 8 times, you got to times these though. 8 times 125 I think is 1,000. Yep. Okay, that's the answer. Okay, next one. Line's already drawn. Make sure every big thing has a direct exponent. That's a 1. That needs a 1. That needs a 1. Direct exponent means it needs to be directly to the top right. So I've got 8, and then I have a 2 and an x. I have the 1 not in parentheses. 1 times negative 3 is negative 3, so 2 to the negative third. 1 times negative 3 is negative 3. Okay, look at the 8. There'd be no need to move that. It's already positive. Okay, that has a negative power, so you need to move that from the bottom to the top. If it has a negative, I don't care, negative power, you need to move it to the other side, so its power becomes positive. That's what's called reciprocating it. Negative, it's on bottom, move it to the opposite side, which would be the top. Okay, 8 to the first is 8. 2 to the third is 8. And then x to the third, and I can take 8 times 8, and that's 64. Okay, I'm crossing out the second problem here. I'm only going to do the first, okay? You put $125 in a savings account that earns a 5% annual interest rate compounded yearly. That means it's 5% added on every year. Find the balance in the account after 5 years. So the balance is money. And there's 2 units underlined, which is why I'm doing that. So I've got dollars and years. I would have the X be represented with years and Y be money. Then per dollars per year. There is no dollar per year, man. It's a percentage increase. And interest is added, so I put plus 5%. When it goes by a percent, it does go up, but not by the same amount, so it should not be just a straight line. So with the curve, it's like a curve shape. You put it times xy, but instead of mx, it's g to the x power. Okay, our money started at $125. Then I have my growth factor. You start with 100% and you plus 5%. So that's 105%. I move the decimal once, twice, and that's 1.05. Okay, now it's time to write our equation. We have $125 times 1.05 to the x power. It is not just 1.05x, it's to the power of x because the multiplication repeats itself every year, equals my y. Well, we're always going to be replacing x, which makes sense because I'm given 5 years, and 5 would be going in for x then. So I take 125 times 1.05 to the power of 5. And I get 159. I'm going to round that up to 160.